We can now look at another handout that you have in your packet for this unit, and that handout is labeled. The handout I would like you to be referring to now is called the relative sizes of sand, silt, and clay particles. If we look at the top portion of this handout, we have some circles or spheres on this handout. These dots, if we let those represent a clay-sized particle, then an average silt-sized particle would be represented by this sphere right here. And if we were to look at a sand-sized particle, one that is in the fine sand or the lower end of the category, it would be represented by a sphere the size of the one that I'm tracing now on the handout. Well, this is a comparison between clay, silt, and fine sand-sized particles. An analogy that was given to me some years ago is that if we let the clay-sized particles represent a basketball in terms of their size, then this silt-sized particle would represent something approximately the size of a two-bedroom house. And a particle that fell in the middle of the textural class sand would then be something approximately the size of Mount Rainier. Well, obviously we don't have basketballs, two-bedroom homes, and Mount Rainiers all existing in a given volume of soil, but I think this analogy is a useful one so that we can begin to understand the huge difference in size between clay, silt, and sand-sized particles. Now, with that large textural grouping of sand, that huge range of effective diameters, we need to take the sand and break it down into some subcategories. And those are illustrated for you here on this handout. The very first category are the very coarse sands. Very coarse sands are between 1 and 2 millimeters in effective diameter. Coarse sand is from 1 millimeter down to 0.5. Medium sand from 0.5 to 0.25. Fine sand from 0.25 to 0.1. Very fine from 0.1 to 0.05. And then, of course, we go into the silt from 0.05 to 0.002, and less than 0.002 is clay. Well, it may seem like this is a lot of memorization between very coarse, coarse, medium, and fine, and very fine sand. But if we take a look at this system of classification in terms of millimeters effective diameter, it's really an easy one to remember because it tracks or follows very closely to our monetary system. That is to say that very coarse sand is from $1 to $2, coarse sand from 50 cents to $1, medium sand from a quarter to 50 cents, fine sand from a dime to a quarter, very fine from a nickel to a dime. So if you follow this and just track it down in terms of our monetary system, those numbers, I think, are relatively easy to remember. Probably more important than you remembering these absolute numbers is that you understand that if we had a soil that had 40% sand-sized particles and that sand was predominantly coarse or very coarse sand, then that type of sand would influence the properties, the physical properties of that soil, quite a bit different than if that sand were fine or very fine sand down here in the lower end of the sand range. So knowing the percentages of sand, silt, and clay puts us into a given textural class name. But two soils, especially those high in sand, will behave quite differently in terms of water relations and aeration, especially if the sand is predominantly coarse or very coarse versus if it's fine or very fine in terms of effective diameters. Occasionally, we have soils that are silt loams, sandy loams, clay loams, whatever they may happen to be, that also have other physical components which cause their properties to be somewhat different. And what I'm talking about here are soils that we would put into what are called specialty classifications. Now, there are two things that can cause soils from a physical standpoint to behave very much differently, even if they are in the same textural class. One of those is the presence of larger than sand-sized particles or larger mineral aggregates. Those soils that have 20% or more particles above the sand-size diameter, which falls into the gravel range, are given the specialty classification of gravelly. Those soils, if the aggregates are even larger than gravel-sized particles, they would go into what are called cobbles. And if they are above the size of cobbles, usually that runs up through about 10 inches in terms of effective diameter, then we get into stony soils. if the size of the rock or aggregate is even larger than cobbles. To give you an example of how this might work, the campus here at Walla Walla Community College is located on a Yakima silt loam type of soil. Now here I'm incorporating the name of a soil series, and oftentimes soil series names incorporate a specific geographical location into that series name along with the textural class. This soil is called a Yakima silt loam. The term cobbly comes in that it has a number of rocks in it that are on a dry weight basis comprise more than 20% of the weight of the solid portion of the soil. And for that reason, this soil is called a Yakima cobbly silt loam soil. And that specialty classification, that specialty textural class name, tells us that we have at least 20% or more cobbles or larger size rocks in there. A second specialty classification for soils, in terms of their textural classification, deals with those soils that have very high organic matter contents. Now, the average range of organic matter for soils in this particular geographical area is from maybe a low of 1% or even a little less than that, up to a high of about 5 or 6%. In the Midwestern region, we may find soils, especially field agricultural soils, with organic matter contents approaching 8%. These are not the types of soils that I'm talking about in this discussion. I'm talking about a soil that has formed underneath a high water, low oxygen environment. So we're talking about things such as peat bogs or swampy type areas or areas that have poor drainage. In those particular locations, we see an accumulation of partially decomposed organic material, and this has a very great influence upon the physical properties of that particular soil. If this organic material is highly decomposed to where we no longer recognize the original plant material from which it came, then these soils are given a specialty classification of muck. If, however, we still see some of the original skeletal formation of that plant material, these soils are given the specialty classification name of peat. So we can either have a soil that is a peat or a muck, and along with the mineral particles in the soil, this is added or incorporated into the textural class name for that soil. So for example, we could have a clay loam soil that was either peat or muck, depending upon the degree of decomposition of the organic material. In coarse textured soils, it takes only 20% or more by weight organic material to add this to the specialty class or to the textural class name. And in loamy to medium or finer textured soils, it takes 30% or more of the weight of the total dry weight of the soil being organic material to add the specialty classification of peat or muck to that soil. So in this general geographical area that we are located in here, we do not find these peat and muck types of soils very often. They're going to be found in isolated pockets. They're going to be found in typically higher rainfall zones, and also in areas where we have swampy, high water, low oxygen environments under which these soils are forming.